Hi, in this video we shall be discussing the third question from CIE paper and its question paper code is this. So now let's read the question. In which structure are three atoms bonded together in a straight line? I'll repeat, there has to be three atoms which are bonded in a straight line. The options are polyethylene, propane, silicon tetrachloride, sulfur hexafluoride. This is a really tricky and challenging question because most of us will be tempted to go with option B, which is wrong. That's not the right option. Let's see how it gets wrong. We'll go with the options one by one. So let's start off with the first one, polyethylene. Polyethylene means you are having n number of CH2 CH2 units linked together. So n number of them means, okay, let's take, this is the first unit. This is linked with the next unit, CH2 CH2. It's linked with the next unit, CH2 CH2. It's linked with the next unit, CH2 CH2. Since it's number n, there is no particular limit to it. It just gets extended. So there are 1 unit, 2 unit, 3 unit, 4 unit, and it just goes on. But yeah, here, the point to be noticed is that each of the carbon atom, there are n units, so there are no 3 atoms, but even otherwise, if you're considering one carbon atom also, it is not having 3 atoms linked in a straight line because this carbon is having a tetrahedral arrangement of the hydrogens and the other carbon to it. For instance, let me imagine, let me suppose that I'm considering this particular carbon, what I've highlighted. So this carbon, carbon has 4 valency. So 4 valency means it will be making 4 bonds, and that 4 bonds will be having a tetrahedral arrangement. 4 electron pairs. Whenever we are having 4 electron pairs around a central atom, it will be taking a tetrahedral arrangement. So we can imagine that it is something like this. So this particular carbon, it is connected to this carbon out here and this carbon out here. I shall again highlight, this carbon is here and this carbon is here. Then there are 2 hydrogens, H and H. So even if I'm focusing on one carbon atom, it is not having 3 atoms in a straight line. So this is the point that you have to keep in mind. So now let's go with propane. Going with option B, propane. Propane is CH3, CH2, CH3. Now let's try to analyze how the atoms are bonded. Each of the carbon atoms are having single bonds only. Single bond means it will be having a tetrahedral arrangement. So tetrahedral arrangement means the first carbon, 1, 2, 3, 4. Going with the next carbon, it's already having a bond. Next, 2 other bonds. Third carbon, already it is having a bond, 2 and 3. So hydrogen, 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 hydrogen. So even if you are having 3 carbon atoms in this molecule, because of which we will be tempted to feel that this is the option. This is 109 degree 28 minutes, or you can say that it is 109.5 degrees, meaning this is not having an atom in straight line. This is not having atoms connected, 3 atoms connected in a straight line. Here also, even if I'm taking a bond elsewhere in this molecule, let me suppose that I am considering a bond here. Again, that is also 109.5 degrees, meaning in propane also, from whichever way we consider, it does not have 3 atoms in straight line. So option A and option B We can rule it out. Let's see. Silicon tetrachloride. Silicon tetrachloride is also having a tetrahedral arrangement. Silicon, its valency is 4, 1, 2, 3, 4, 4 valence electron. And that is making 4 bonds with chlorine atoms. 1, 2, 3, 4. This molecule also doesn't have atoms connected in a straight line, or in other words, 3 atoms connected in a straight line, because having a tetrahedral geometry, each of its bond angles are odd, or all of its bond angles are 109.5 degrees. Hence, this is also not the option. And sulfur hexafluoride is the answer. Let's see how. So coming to sulfur hexafluoride, sulfur belongs to group 16. Group 16 has 6 valence electrons, or electronic configuration. If you want, I can write it. Electronic sulfur is atomic number 16. So its electronic configuration goes like 2, 8, 6, or it has 6 valence electrons. So here I go. Sulfur 1, 2, 3, 4, 5, 6. These are the 6 valence electrons of sulfur, and each of them will be connected to 1 fluorine atoms. There are 6 fluorine atoms. So we can assume this is connected here. This is connected to the next fluorine. This goes for the next fluorine. This is connected to the next fluorine. This is connected to the next fluorine. This is connected to the next fluorine. This has these fluorine atoms in a plane. These fluorine atoms will be in a plane. These two will be perpendicular to the plane, meaning you consider any fluorine, sulfur, fluorine diagonally opposite. Any fluorine, sulfur, fluorine atoms diagonally opposite, they all will be in a straight line. We have 3 atoms in a straight line. For instance, let me highlight. I shall highlight it once again. Fluorine, sulfur, fluorine. All of them lie in a straight line, diagonally opposite to the corners of a square. This is having, basically because this is having an octahedral geometry. So all other options are wrong, because in all other options, the central atom carbon or silicon, carbon in the first 2 molecules and silicon in the third option, third choice, all of them are having tetrahedral arrangement of atoms around the central atom, whereas this is having an octahedral arrangement of atoms around the central atom. So this is the answer which will be having, this is the molecule which will be having 3 atoms connected in a straight line. That's all for now in this video. Thank you.